Welcome to aminacademy.com. In mathematical economics, let us discuss about derivative and rules of differentiation. In that, we will discuss about limit and continuity. In economics, the calculus is used to study the record complex information commonly on graph and curves. Calculus allows for the determination of a maximal profit by providing an easy way to calculate marginal cost and marginal revenue. It can also be used to study supply and demand curves. Now let us discuss the basic things of limits and continuity. Limits are essential to calculus and mathematical analysis and are used to define continuity, derivative and integrals, etc. In formulas, a limit of function is usually written as and is read as the limit of f of x as x approaches c equals to L. Look at this definition. The formal definition of a limit is given by, for a function f of x, the limit f of x as x approaches as equal to L denoted by limit of f of x equal to L. Now let us discuss about some formulas of the limits. Look at here. First one, limit x approach a, that is extends a, f of x we can tell as is L. Now suppose limit of the value k is a constant, x tends a itself equal to k only, because it won't affect the limit because k is a constant, but here x tends a. Limit x power n x tends a gives x power a, because we are substituting now a power n. This is x as a over n. Next one, limit of k into f of x, that is x tends a, gives the k come out of limit x tends a f of x, because the constant is not affected with limits, so it take out as of limit. Next one, limit of x tends a of f of x plus or minus g of x. Here the two function is under limits, so we can write the limits as separate. That is limit of x tends a f of x plus limit of x tends a g of x. Addition and subtraction we can write here. Next one, limit x tends a f of x into g of x is similarly the limits x tends a f of x into limit x tends a g of x. For division also, limit x tends a f of x over g of x equal limit f of x tends a of then divide limit x tends to a g of x power like limit x tends a f of x over n is the same limit x tends to a f of x that whole power n, where n should be greater than 0. Now these are the some useful functions formula for limits. Next we'll talk about the continuity and differentiability. Look at this graph. It is the graph continuously going. That means there is no interrupt. But here it's not continuous because this interruption point is here. The curve is not continuous. Continuity and differentiability is closely related concepts in calculus. A function is said to be continuous at a point if its graph has no breaks or jumps at the point. A function is said to be differentiable at a point if it has a well-defined tangent line and that point. And that point there should be a tangent. The differentiability implies continuity theorem states that if a function is differentiable at a point, then it is also continuous at that point. However, the converse is not necessarily true. That is, a function can be continuous at a point but not differentiable at that point. The derivative gives the slant of the tangent line at the point, and the slant of the tangent line can be utilized to decide whether the function is expanding or diminishing at that point. So continuous function simply definition is first one f of x is defined that is exist, that is we can say it is exist at x equal to a limit of f of x tends a exist, it must exist. And third point, limit x tends a f of x must be equal to f of a. Slope and curvilinear function, that is slope of a curve. Finding a slope of a curve at a point is that the two fundamental problem in calculus. This abstract concept has a variety of concrete realization, like finding the velocity of a particle given its position and finding the rate of reaction given that concentration as function. But here the slope goes like at some particular point the slope is horizontal to x-axis, that gives the slope is 0, and that point this curve has the maximum value. For example, normally slope can be defined in particular curve. Slope is y2 minus y1, that is second value minus first value of y, over x2 minus x1, second value of higher value of x minus lower value of x. Now in suppose if x2 equal to x1 plus change in x and y2 f of the function f of x plus delta x. Then slope can be written as f of x1 plus delta x change in x minus f of x1 over change in x, delta x. Change in function, change in x. For example, find the slope of f of x is given as 2x squared. Employ the specific function in algebraic formula. Then we put slope here. Slope is equal limit delta x tends 0 f of x plus delta x minus f of x over delta x. In that, look at here, the function is f of x equal to 2x squared. Therefore, we can say limit delta x tends 0 2 into f of x equal x plus delta x the square, that is f of x plus delta x the square minus f of x is 2x squared over delta x equal to delta x. That means the function in the function x gets increment of delta x, and here the minus original function. This is the definition of slope in that. Therefore, slope of the function is limit delta x tends 0 to into expanding x plus delta x the whole square is x square plus x delta x plus delta x square minus 2x square over delta x. Now limit delta x tends 0. Here x is here, open this one, this 2x square, which is equal 2x square plus 4x delta x plus 2 delta x square minus 2x square over delta x. Here 2x square and 2x square cut, which gives limit delta x tends 0. Here 4x, remaining things 4x delta x plus 2 delta x square over delta x. Now we are dividing both by delta x. Limit delta x 0, 4x delta x by delta x plus 2 delta x square by delta x. Limit 0, this cut 4x plus the square cut, that is 2 delta x. Now applying the limits, delta x tends 0, there is no delta x term here, that becomes 4x plus delta x tends 0, here it becomes 0, 2 into 0, which is equal to 4x. Therefore, slope of a function, slope equal to 4x. This is the basics of differentiation. That means the first rule of differentiation made call. So far we discussed about uses of uses of differentiation calculus in economics, as well limit, continuity and differentiability of a function and slope of the function. We have done. Please subscribe our YouTube channel.